Okay, let's look over this, guys. Remember, we have the probability of A and B. So that's the probability of A times B, okay, our multiplication rule, equals the probability of A times the probability of B, assuming A, which means the probability of B after A already happened. Notice the A and the B are next to each other. It's not the same letter. That also equals the probability of B times the probability of, if this is B, it has to start with A. They're different, guys. The only time they're the same is when we're checking for independent, dependent. Okay, so our first one, we have the probability of B is 0.7. And we have the probability of A assuming B, which is 0.5. And if we look at our model, it's right here. So we just multiply those together and it equals the probability of A and B, which is 0.35 or 35%. The A and the B, guys, is always by itself. Don't mix it with any of the other ones. So on the next one, we have the probability of D, which is 0.62. And these can be any letters, guys. They don't have to be A and B. They can be C and D, E and F, whatever letters they choose. Okay, times something. And we're also given the probability of C and D. So remember, these have to be separate sides because this one is always by itself. Okay, so that one's 0.39. So what are we missing here? I'm missing the probability. Can it be a D? No, it has to be the other one. So it's C, assuming D. Okay, which we would solve for. It's X, multiply them. So just divide by 0.62, divide by 0.62, and you would get 0.629, which is also 62.9%. All right, last one. So we have the probability of A, and we have the probability of B assuming A. So those are different. We just multiply them, and that equals the probability of A and B. Okay, so we're given 0.6 and 0.45. All we have to do is multiply those two together, and you get 0.39 or 39%.